Hello, so today we're going to start learning simultaneous equations. The goals will be to correctly find the solution to a pair of simultaneous equations, simultaneous linear equations using algebraic methods, and then relate the concept of solution to simultaneous equations to its graph. Now, it's very important that we recall the concept of solutions, okay, to a linear equation. And remember that it's basically a number that satisfies the equation or makes the equation true, or a value of the variable that makes an equation true. Now take note that previously we've been working with linear equations with one variable, and so only one value will make the equation true. So for example, we have x plus 5 equals 12. We know that the solution to this is x equals 7 because x equals 7 makes the equation true. So 7 plus 5 equals 12. 12 equals 12 makes the equation true. So we say that 7 is the solution, and that is correct. However, we will be working with example 1. Okay, we'll be working with excuse me, equations with two variables. And so let's have an example. X plus y equals 10. Okay, now as you can see, there are two variables here, x and y, and so there will be a solution that has a value both as an x and a y value. And if you think about it, there are several solutions to this one. So x can take any number and y can take any number as long as they add up to 10. So the solutions can be x equals 2, y equals 8, x equals 3, y equals 7, so on and so forth. Okay, now this is called a linear equation in two variables, and we know that if we graph that, okay, we learned that before, that if we graph this and take different values that satisfy this equation, we'll form a straight line. Okay, now suppose we have another equation, which is 2x plus y equals 14. Similarly, there are several values that can satisfy this equation. So we can say x equals 2 and y equals 10. We can also say x equals 3 and y equals 8. And it will all satisfy this equation. And again, since this is a linear equation, okay, just remove that s there. Okay, we know that this is a linear equation. Now, remember that linear equations have a straight line graph. And so if we have, for example, a random equation, okay, we know that if it's a linear equation, it will form a straight line. So we say that that's the graph of a linear equation. And so, okay, therefore these equations here can actually form graphs. Okay, now suppose we graph them, and let's just say that this red one is the first one and the blue one is the second one. Okay, we can see that if they're straight lines, they can only meet once at one point. Okay, that's their intersection. and the coordinates of that intersection actually forms the solution for both equation. Okay, so that point there, the values of x and y at that point satisfies both equations that you're working on, one that forms the red line and one that forms the blue line. Okay, and that's basically the concept or the solution for simultaneous equation. When you're looking for the solution for a simultaneous equation, we can write that down. The solution to a pair of simultaneous equation. Just here. Is one, the coordinates of the point where the graphs meet, and two, the values of x and y that satisfies both, oops, why is there an e there, equations.